In this video, I'll present the concepts associated with linear momentum and collisions. That's Walker Chapter 9. So the big thing here is conservation of momentum. Momentum has units of kilograms times meters per second. So meters per second, that's a speed or velocity. So velocity times a mass. Momentum is a vector, okay? Energy, we just did energy. Energy was a scalar. Momentum is a vector like acceleration, like velocity, like position and displacement. All components of momentum are always conserved for any closed system. So that means the x momentum, the y momentum, z momentum, whatever directions you have, momentum is conserved in every direction in a closed system. So a closed system is one that does not have forces from outside acting on it. Impulse. Impulse, you'll see, has the same units as momentum, and actually I very rarely use the word impulse. Impulse is just a fancy name for change in momentum. If two things hit each other, usually the interaction takes place in a very small amount of time. And so it's an impulse in that it takes a very small amount of time to change the momentum. An elastic collision is one where the total kinetic energy is conserved. Now for our purposes, we're going to say conserved is 80% or more. So if we're looking at a collision and 80% of the kinetic energy is conserved, we'll call that elastic. Collisions where objects bounce are generally elastic or very nearly elastic collisions. An inelastic collision is one where kinetic energy is not conserved. Okay? Now remember, in a collision, momentum is always conserved. Kinetic energy is not. Okay? Kinetic energy is not conserved in an inelastic collision, and collisions where objects are permanently deformed, think of a car crash, or stick together. So a wad of clay hitting something. If two things stick together or are permanently deformed, this is definitely showing you that it is an inelastic collision. They might still bounce off of each other. So just bouncing off of each other is not enough to say it's elastic. You have to look at how much kinetic energy was conserved. If they stick together, it's enough to say, yes, that one was inelastic.